Now that we have talked about the absolute value parent function in a little bit more detail, we're going to talk about the quadratic function today. So the shape of a quadratic function is a U-shaped graph, and the name of this graph is called a parabola. So this is the sketch of a quadratic function. Its domain is all real numbers, and its range is y's that are greater than or equal to 0. This graph also, just like an absolute value graph, has a vertex, which is the lowest point on the graph. It's going to be right here. This point is called the vertex. It's at 0, 0 for the parent function, but it might move somewhere else. And because it also has symmetry, this vertical line, this imaginary, invisible vertical line down the center, is called the axis of symmetry, and it goes through the vertex at x equals 0. Now, I made the same mistake. I think I copied and pasted. These inequalities are backwards for increasing and decreasing. We are decreasing to the left of 0 and increasing to the right of 0. If you imagined like riding a roller coaster, we're falling and then we get to x equals 0 and we go back up on the other side. So we are increasing when x is greater than 0. On the right side of 0, we're increasing, and we're decreasing when x is less than 0. So the table of values is given here at the left, and remember, the y values are what we get when we square the x value. So negative 3 squared is positive 9, and negative 2 squared is positive 4. So you see we get this like bounce back between all of the x values, which is why we get that symmetry on both sides of the graph. Now, a linear function has a constant rate of change. A quadratic function does not. So if we look at the differences between the y values for each of the functions, we've studied linear functions extensively, and what we know is that linear functions have a constant rate of change. The rate of change between each of the y values is the same. Now this is the parent function y equals x. Every single time that y value is increasing by 1. It's a constant rate of change of 1. We know the slope of that line is 1, and that's why the line is straight. It's not a curve because it has that constant rate of change, a slope of 1. However, the quadratic function, if I do the same thing and compare all of the y values, we'll see that we don't have that constant rate of change at all. I have minus 5, minus 3, minus 1, plus 3, plus 5, plus 7. The rate of change is changing. It's not the same between every single one, but if I go ahead and do that a second time and compare the rates of change of the rates of change, I do see a constant change here. And so it's the second differences with a quadratic that end up being constant. What that tells me is it doesn't have a constant rate of change, but the rate of change of the rate of change is constant. And so if we go back and kind of look at the graph here, what does that mean? This is why we end up with curved sides on a parabola. Normally, a line that has a constant rate of change is up 1 over 1, up 1 over 1, up 1 over 1. That's the linear parent function, constant rate of change like that. But our graph is up 1 over 1, up 3 over 1, up 5 over 1. That rate of change is changing, and so that's why we get this curved shape here, because it's getting a little bit steeper and a little bit steeper every single time. So that's kind of why a parabola is always going to have curved sides, okay? So similar to an absolute value function, knowing what we know about transformations makes it easy for us to figure out what the vertex of a parabola is going to be. It's going to be HK. But since a parabola doesn't have straight sides, we can't just use A to give us the slope because it's not going to make a straight line. So it's a little trickier to deal with the stretches and shrinks. So we'll talk about that a little bit more when we get into graphing. Today we're just going to talk about some of the characteristics of a parabola. So the value of A will give us the stretches and shrinks, but it'll also, just like with absolute value, tell us whether it opens up or down, because that'll tell us if it's been reflected across the x-axis. So we're going to talk about several forms of the graph, or several forms of the equation of a quadratic function. But the first one is vertex form, and this is the one that indicates the transformations that have been done. So we have f of x equals a times x minus h squared plus k. So h and k tell us our horizontal and vertical translations, and a is going to tell us a reflection if it's negative, and it's going to tell us a stretch or shrink. So remember from here that the vertex is going to be at hk, just like with an absolute value. And the axis of symmetry is always going to be the equation of the line x equals h, just like with absolute value as well. So we can look at just the equation and determine some of the things about it. So for number one, this equation, the first thing I notice is the value of a is negative. So these examples are asking us to tell whether the parabola opens up or down. That's going to come from the value of a, and then determine the vertex. So does it open up or down? This one opens down, and I know that because a is negative. So this parabola opens down, and then the vertex is going to be at -1, -3. Remember, we always switch the sign on h, keep the sign on k, k for keep. And then it didn't ask us for it, but I'm going to go ahead and give the equation of the axis of symmetry, which is going to be x equals -1. Remember, it's x equals because it's a vertical line, and it's always going to go through the x coordinate of any point, and the vertex is where we're looking at. So it's x equals -1, okay? That's all there is to it. It's going to be the same for all of these. So I'd love for you to pause your video and see if you can list out up or down, vertex, and axis of symmetry for 2, 3, or 4. I'll be back in 2 seconds with those answers. All right, here we go. So number 2 opens up. The value of a here is 1. So it's positive, which is why we know it opens up. That also means that there's no stretch or shrink here. It's just equal to 1. And whenever we don't see a value for a, it has to be 1. A lot of times we want to say 0. If that was equal to 0 times x minus 4 squared, then that whole thing would be equal to 0, and we would no longer have a quadratic. So it can't be 0. The vertex is 4, 7, which means the axis of symmetry is x equals 4. Now on 3 and 4, sometimes we have a hard time deciding when either h or k is missing. Remember, h has to be inside parentheses in order for it to be underneath the squared. So that's how I know that this -5 has to be giving me the value of h. And then there's essentially a +0 out here, which makes it the k. Okay. This second one here, the negative is how I know that it opens down. And then because this +1 comes after the squared, I know that that's k. And so my h has to be 0. This essentially looks like x plus 0 squared plus 1. Okay, so that's how I know that h is equal to 0. All right. Now, because we know how a parabola behaves, we really don't even have to see the graph to be able to decide what the domain and the range are. We know the domain is always going to be all real numbers, and then the range is only going to change based on the vertex and whether it opens up or down. The vertex is going to tell us either the highest point or the lowest point, depending on whether it opens up or down. And so the y value is always going to depend on the k of the vertex. So if the parabola opens up, our range is always going to be y is greater than or equal to k. And if our parabola opens down, then it'll be y equals less than or equal to k. Every single time, that's how it's going to work. So same question, determine whether the parabola opens up or down, the vertex, and the domain and range of the function, just by looking at the equation. So number 5, I see a positive a value, so I know that this graph opens up. And if it opens up, it looks like this. So that means that my vertex is the lowest point on the graph, so I know my range has to be a greater than or equal to whatever. And I know that whatever is going to be whatever k is for my vertex. Well, I know that my vertex for this graph is -1, -5. I know that the domain is always going to be all real numbers. And so my range is y greater than or equal to -5, because that's the k value. Go ahead and try number 6. Pause your video. I'll give you the answer in just a second. So this one opens down because my a value is negative. the vertex is positive 4, 0. And since it opens down, the domain is always all real numbers, but the range is going to be y is less than or equal to, since it opens down, 0, since that's the k value. And that's it. So that's just some practice with the characteristics, and we will practice graphing in the next video.